Excellent. So good afternoon, everybody. Thanks for attending. My name is James Gress. I lead the North America Advanced DevOps Center out of our Tampa Advanced Technology Center. We put this meetup together to talk about the latest and greatest stuff within DevOps and what that stuff looks like in that space. We are always looking for speakers, so if you're interested in speaking, please reach out to me. I do have some interesting stuff coming up for the DevOps Days 2022 coming up. A few of the leadership committee on that are starting to set dates and venues. If you are interested in volunteering, please reach out. We need more organizers to help actually pull off that event. It will be in person, or at least that's the goal, to have it in person. We'll see if that is able to pan out based on what's happening with the pandemic, etc. But it'll probably be June, July of next year, and hopefully everybody's ready to start, rubbing shoulders and being able to actually see people in person, etc. As far as this meetup goes, we are going to target February-ish to have a live in-person event. Not sure exactly what that's going to look like. However, we are remodeling our office, and one of the considerations was being able to host these types of events. So it's going to be pretty exciting for us to not only have a fresh brand new office, but be able to host these types of events in that office. This will be a recorded event and posted on YouTube within a couple of days. Quick guidelines for this call: please try to stay on mute unless you're asking a question. This just helps reduce some unnecessary background noise. We do encourage video, as it helps to make our event feel more socially engaging. At the end, we will open it up for questions. However, if you do have a question, Hugh is going to take them throughout the presentation. So just raise your hand, ask something in the chat, or just unmute yourself and then go ahead and ask that question. After the meetup ends, we will be raffling off a $100 Amazon gift card courtesy of Curiosity. And today's topic is going to be on data is make or break for DevOps. I know that for me, this is a high area of interest, and many of the clients that I talk to have a lot of pain points in this area. Over the last few years, I think overall, most people have gotten their CI/CD process down on applications. Over the last few years, we've seen a giant push on infrastructure and embedding that in with the DevOps pipelines, et cetera. I think the clients are now realizing that data needs to now follow suit and come into the fold, where some clients may have had good strategies on this or have started a little early. I think there are still a vast majority of our clients that will be embracing this over the next few years. So I think this is a great topic to be talking about now and to watch, how that's going to materialize over the next few years in the DevOps space. So from here, I'm going to let Hugh talk about how Curiosity has a viewpoint on this and what they're doing to help clients mature their DevOps processes by making data more available across the landscape. So Hugh, I'm going to hand it over and let you go ahead and take it over.
Thank you so much. I'm actually going to say hello on my video, and then I'm just going to stop the video. I'm in a hotel at the moment. I don't want to waste the bandwidth. So just to give you a little background, you guys can hear me okay, right?
We can.
Yeah, just to give a little background about who Curiosity is. I've been the test data and data space for way too long. We were the company called Grid Tools, which then got bought by CA, so the CA TDM products, and now latterly the Broadcom products. But over the last sort of 2 or 3 years, we've kind of re-entered the market, mostly because our old customers said, "You've got to come back. We're struggling," which was good because it allowed us to kind of come in with a lot of experience, but a fresh pair of eyes. And I think that has coincided with an actual sort of change in the way that people develop. There's obviously the kind of move to agile, and I'll use the capital letter A, but also the small letter A in terms of, sort of continuous development, and then the growth of CI/CD, but also the growth of containerization, microservices, and the move to cloud, which has allowed a kind of rethink, but also an ability to take advantage of the really, really cool tech that's around nowadays. GitHub provides just a vast array of really cool stuff, and what we've been able to do is kind of, take some of that and enhance it, as well as building our own kind of clever stuff as well. So it has changed. It used to be kind of very monolithic approach to it, but now you can be very nimble. And what I'll try and do as I'm going through is just give a few examples of what we're doing with other customers and what we're seeing out there in the kind of market space, I suppose. Anyway, enough of a preamble. Okay. We kind of call it test data automation now, instead of just test data management or environment provisioning. It's kind of test data automation. It's kind of automating test data. So, people are always trying to build, use, Selenium scripts and, API testing and all those kind of things. But actually, if you kind of apply some of the same techniques and same of the technologies using automation technologies, and that's a lot of what we do, you can actually then make it reusable and make it quicker, make it repeatable, and actually drive through a better test data strategy using this idea of kind of automation to drive everything. So just to kind of give you a little agenda, it's kind of, Databricks DevOps, automate data allocation and data finding and data making within CI/CD pipelines. And then sort of, I'm going to jump into a few random demos, depending on, most of my demos are a bit random. That's usually the stuff I'm working on at the current time. But I'll hop in, and the idea is just to kind of get you thinking about maybe a few different approaches and techniques to be able to do that. Okay, so the thing about test data is that everyone's doing it. People say, oh, I think I've occasionally come across some companies who say, yeah, we've got that completely organized, which is, I'm staggered, because no one's ever got it completely organized. You're either, you could be a project team waiting for another team to finish working to be able to give you the tables with all the APIs for you to be able to go and, access their data. So, for 2 or 3 weeks, you might be waiting. You might be doing a migration, probably about 20% of projects are actually migrating applications. And a lot of that actually is to do with migrating and the data, and also understanding the data as well. So, or even if you're a developer and you're trying to test a particular if statement, if else. So you do spend an incredible amount of time. Now, the thing about that is it's not very predictable, because you might say, well, I'm just about to, let's create there was another one. Let's create a training database. About to roll out a new system. You've done all this lovely work. You created a fantastic, little, expense integration system, but you can't really put it out with live data. So you say, well, I'll just create a training database. It could take you a couple of weeks to do that. That wasn't really in the plan. You want to suddenly do some performance testing and say, oh, we need 2 million rows of data, or 2 billion rows of data, which is what I had to do the other day. And you're struggling with, we haven't enough space, to put that inside our databases, and all those types of things. So it sort of hits you in a million different ways. And it is a sizable chunk. I think Tom, who's on, there's various research that it can be anywhere from sort of minimum 5% up to about 50% of project time can be wasted, or not wasted, sort of spent messing about or playing with data. I think a lot of time is, people tend to think about finding data. Oh, I need this particular piece of data to test with. I need this particular scenario. And they'll go off and they'll try and find the data, and then they'll go, oh, we haven't got one of those. So what do I do about that now? Oh, let me make it. And then suddenly they go, well, I can't make it because I've got to put an MQ message up to create the customer transaction on the mainframe. Oh, so I've got to go and get access to the mainframe now in the development environment, but their system's down. So making missing data. The other one is competing for data. And that is that, you kind of trample all over each other, because you someone will copy a mass copy of production data down, and bang, you've lost all your lovely data, which you've just spent 2 days setting up to be, in a nice state. Or you, in automation, actually, it's quite, someone adds a new automated script. And what it may do, we had an absolute doozy where they added an automation script that sent someone on holiday on an HR system. And what they did is they sent the manager on holiday, and the manager was used in the subsequent 999 other scripts. So once the manager was on a holiday, they were unable to do any of the activity. So suddenly the entire regression pack worked because of the addition of one extra automated test. There's things, a lot of test failures, this failed. Oh, and then you go and look at the code and you look at the requirements, and then eventually you work out that actually the test data was incorrect, and that it isn't a bug, and you can actually spend an awful lot of time to sort of chasing down these things which are actually not problems in themselves. I think wrapping testing and development today needs data that is complete. Now, complete is a very big subject. What is complete? Does that mean that you can test every single line of code? Does that mean you're testing every logic gate? Are you testing the requirements, or are you testing the code? Every test. What kind of tests do you have? And do you have enough tests? Are your tests risk-based? Do you have negative tests? A lot of bugs in systems actually come from bad data making it into the system, which then causes problems downstream. So you might want to test all your validation routines to make sure that you can't get bad data in, especially if you're receiving groups receiving data from external sources, which you could well be via APIs, etc. Up to date, one of the problems you have is that if you just copy production data and you put it into development, it's kind of out of date almost immediately. If you've got any kind of real-time, order management systems, you can then spend ages sort of hacking around with the data, trying to sort of bring it up to date, and there's a lot of hacking that goes on. Compliant contains no personally identifiable or commercially sensitive data. I think the one that people forget about is commercially sensitive data. If you drop your production, you might say, oh, well, there's nothing in here. It's just pricing data. We're going to drop the pricing data, the pricing calculations data into development. Then if someone gets hold of that, and a lot of that's where hackers find it easier to get hold of data, because it's sort of lurking around in, it's been dumped out in log files or whatever you want to see, and you can basically then get hold of all sorts of information about the pricing strategies of the company from the commercially sensitive data. Consistent, now systems never die, they always get sort of linked together. So there's a lot of integration that goes on, and trying to create data that's consistent between them is very hard. The old days of a mainframe, one database, you could create some data in there, but pretty much the idea of the front end, the reports and the batch systems, was using the same data. Now you could have, if you look at some of the banking systems, there are thousands of systems that might at some stage rather be used to just vest a share. And the big thing is the speed, parallel testing, automated testing, containerization, and whatever new accelerator arrives tomorrow or today. We are constantly finding new pieces of technology that's arriving in the landscape. It could be a variation, it could be some kind of new big data adapter or whatever it is. Some cool piece of technology's arrived, and suddenly you've got a whole new piece of tech that you've got to sort of get around, understand, populate, integrate, etc. So did we talk about, to make sure, I'll talk about compliance a little bit here in a second. So the reality for testers, constantly later on available. You guys can read this. That's pretty much what I've said. Poor variety for functional testing. I would say that we haven't done this for a while, actually. We did about 10 years ago take a full production system, and what they'd done is they'd put code instrumentation on their entire code stack, and they ran through their end of month transactions, and it was roughly about 20% of the code was being exercised using production data. So that's a problem, because whenever you get something that's slightly out of the normal, or then you're probably not testing that if you're using production data as your main driver. So you've got to think about the variety in functional testing. And the idea is, and we do have some tools that compare the granularity of the data in production and development, and what that will do is show you how good the data is and what the differences are, and then what you can, it sort of gives you a good metric in terms of, okay, these are the different types of data that we have. Now what we want to be able to do is to make sure that the data in the development and QA environments is actually richer. I think that's a sort of a good rule of thumb than production data. Production data is just, you're interested in the characteristics of production data, but the reality is you shouldn't really care that much about production as long as you kind of understand the data that's in there. So, there's this, if you bring down data from production, you've got to think about all the other types of things. I've sort of talked about, negative scenario outliers, invalid combinations. Historical data is a good one. It's very difficult with kind of live systems to create historical patterns of behavior. And a lot of the kind of, business intelligence, machine learning, AI tools actually are looking back at past behavior to be able to say, well, okay, now we want to predict what our customers are going to be doing. So to do that, you do actually need to have quite a lot of historical data. So there's all sorts of different types of data you've got to kind of think about when you're sort of creating and understanding what you actually mean by quality in data. Now, compliance, speed, agility, and quality. I'm just going to talk a little bit about compliance. Now, you guys in the States have, sorry, I'm just going to have a drink here, one sec. You guys in the States, we're an Irish company, so we're governed by Gdpr law. If you're a US company, you have slightly less rigorous laws, but they are sort of improving. As usual, California, I think, is probably leading the way in terms of some of the compliance things you have to worry about. The other one is if you're a multinational and you do hold European data, you are actually bound by the GDPR laws there. Now, there was an interesting and they're getting very strict, and also they are fining significant amounts of money. There was a case in Norway about a month ago where they actually fined a Norwegian company because although they were using production data and they had significantly masked the data, they had gone through and changed the names of all the people. What had actually happened, they said that they were using too much data and they hadn't paid enough attention to being able to test using synthetic data, and they fined them, which is the first time that we know of that companies have been fined for using masked data in their development environments. So I think that world will increase. It's not going to go down. Some companies, well, I've only ever come across one that does it fully. What they do is they have a separate development environment where they're actually where they have like a fake bank, and they put through daily transactions every day. They have people sitting there in the development environment using the system like they are customers, like they are users. So that means that all of the data there is fake. They have fake names, fake etc. But they're actually people putting that data through, and that's actually a very interesting way of approaching it. Just try and simulate the behavior in the development and testing environments. So you're adding in orders every day. You're issuing price changes, whatever it is. Speed and agility, teams and frameworks have exactly the data they need on demand and parallel. Parallel is important. I'll show you a little slide in a minute, which is a very interesting approach that we're seeing more and more of nowadays, and that does help an awful lot with a bunch of things that we're working on. So I'll come back to that one. And I've talked a little about quality. Teams and tests have all the data they need available on the fly as they test. The data that they need is actually linked to the requirements. So you need to think about test data as something that is built into the requirements. It's sort of, this idea, we have a requirement, we do some code, and then we do some testing. For testing, we need data. If you haven't specified the data that you're going to be using in the requirements, then you're swimming upstream to try and interpret what the code's doing, et cetera, et cetera. So actually thinking harder at the beginning about how you actually construct your requirements. We're sort of moving towards color coding on the requirements documents. So when you have an actual physical piece of definition of a table or a column, it's a certain color. If you've got a business concept, which might be something like a post, then it's a different color. A post account, but that post account then has a definition in terms of the data that it's actually going to be operating on. So that's an interesting space to think about how you actually just spend, maybe spend a day or two just reconfiguring some of your requirements documents or changing, adding some extra fields into your JIRAs or whatever it is that you're using to be able to do that. So test data automation, complete and compliant test data available on the fly. I'm just going to talk about this. This slide is a sort of we did a presentation to a telecoms in Europe the other day, and I used this slide, and it provoked quite a bit of discussion. So there are various tools out there that do masking. We have masking engine, and quite often people will take a copy of production data and mask it. That is if you actually have access to the data itself. If you're using some of the ERP systems, this can actually be quite problematic because you don't actually have that capability to get at the back end data, and you might end up having to load data in into a blank database and scrub the data loads to be able to get that data in. But for the moment, we'll just say we're masking the data. Then you get into the wonderful world of virtual databases. Now, the tech is kind of around, in Oracle and SQL Server anyway, but with the advent of Docker and containerization, it's very easy now to take a 2 or 3 terabyte database and kind of squish it down and have just a 2 gig footprint. Now the advantage of that is that it means everyone gets their own copy of the data, which is very useful because you don't step on top of each other, which is fine. 1, 2, 3. And I'll show you, we've got some really good integration with a great company called Windocs, who we really like, really nice company. I'd encourage you to go and have a look at some of the stuff that they do. Very easy to set up, and bingo, I think you can have like 250 databases on one Windows server, which is quite impressive, or Linux server. Now there's another one, which is subsetting and masking. Now, subsetting is where you actually crawl across the database and you just end up with a smaller set of data, and then you do the masking. Masking does take time. If you're running through a 2 terabyte database, changing all the names, it does. You can do a lot in parallel. But if you're messing around with any kind of primary keys or account numbers, which are keys, then you've got to drop and recreate indexes, and it can be quite hard work. So sometimes, going down the route of subsetting is a nice way of doing it. Another way of doing it is actually to just have ad hoc requests. So you just say, right, I need an account that has these characteristics. Go to production, find me an account with those characteristics, and bring it into my development environment. When I do that, make sure that it's masked. So you could go and find an account with 5 years customer activity on it, and then you just bring that in, and it gives you and it would basically give you a new account number to deal with. So you got your virtual databases. Now, the thing that we're doing an awful lot of is the conditioning engine. The conditioning engine is, and I'll show you this in a little bit, is basically an ability to, if you take a look at the people who are using data, now you could have some automation, you might have some developers, you might have some testers. Now, I'm going to use the phrase SQL here, which is, structured query language, standard query language, which is the database lookup language. Now, it doesn't have to be this. It could be, you might be finding data in messages or whatever. It doesn't particularly matter. But for the time being, we'll just say SQL. And that SQL is the SQL that you are going to be running for your particular piece of development or your particular piece of testing. Okay, so what we'll do is we will look at the SQL that you're about to run and say, well, okay, we are going to take the database that you've just brought down from production and masked, or maybe take one of your other databases or another development database, and we're actually going to find the data. If we can't find it, we'll make the data. And that is actually quite a revolutionary way of thinking about it. So you try and get that data to be, when the database comes over, it's provisioned with virtually all of the data that you're going to need. This could also apply to messages as well, by the way. If you need to create sets of messages, you could create them, have a look at them, see what's missing, and then just go off and actually just supplement them. You then have this concept of kind of ad hoc stuff. Now, ad hoc is, I'm going to go and request some data, and we'll just do exactly the same thing. We'll say, well, what are you going to try and run? Oh, well, you're going to try and run that. Fine. If we can't find it, we'll go find some similar data and we'll make it. Okay. And then the other one is to build a model of the variations of the data that you're going to need. And this brings in the, BDD, this sort of idea of model-based testing or model-based design. And out of that, you can then just, in effect, construct the data for all the varieties and variations that you're actually going to be using in your development and testing world. Okay, I suppose from the point of view of kind of DevOps, this is the kind of one you're kind of focusing on to make sure that all of your automation packs, as you're releasing code, have the data that they need to be able to satisfy all of the automated tests. Okay, so I guess that's sort of an interesting space. I'm just going to hop into a little bit of a demo, assuming just for 1 second. So I'm just going to kind of show you. So if you want to find some data. Now, people could go in and, they could come in and they could basically run some queries. I need, certain types of data like so, and I'm just going to go and see if I can find it. So what we could also do, actually, let me just go and do, just doing some work for Norway. And what you can do here is you can come in and say, well, how many do I want? Well, I need 10 of them because I'm going to do a fair bit of testing. Now you could cast a query in here. You could look for drop downs. You might want to say, well, I want a certain age, I want them to be beyond a teenager and 99. How many policies? Well, they must have a couple, and you basically, what you're doing here is you're basically constructing a way for people to request the data that is coming through the system. Okay, now I'll just do one more, which is, so say, for example, if we just go over to Oracle for a second. So here over in Oracle, what we've got is this is a nice little example, actually. It's a very simple example. You've got customers, products, etc. But even within just a few tables here, there is actually quite a lot of potential complexity in terms of things that you would be typically looking for. Now, a good way of doing it is actually to create cubes, because a cube is it's a sparse way of looking at data, which means you can come in and say, well, I'm interested in customers that have high shipping, that have orders that haven't been shipped. When was the last activity? And all you're doing is constructing a way of looking at the data to be able to do that. Okay. Now, if I look at the queries, I think of these as the queries that I need to satisfy, because this is a little business intelligence testing system or a dashboard I'm working on. And you'll see that I don't particularly have much data here. I've got 30, 33, 0, 0, 0. So when the tester or developer starts working, they're not really going to have enough data. So what we do is we will go off and just go, and we will create a little pack of data. So, and all we do is we just store the SQL that we're going to need to run. Okay, so we have this SQL here, and all you have to do is just add any SQL into this particular, we call it a list, which is basically a pack of data that we're going to need to be satisfied for this particular environment to run successfully. Okay, and then in the world here, all we would do is just go off and 1 second, basically run our conditioning engine. You can override values. So for example, what I want to do also is I want to actually just change the dates so that I'm going to move my dates forward. So I'm actually changing the maximum date. So one of my in this case, I'm going to do a generate, and the generate is actually just going to push the dates forward. So I'll take, for all those queries, the dates will actually be over the last day or two with a maximum date like that. Now, when I fire this off, this is where the wonderful world of sort of cleverness has now arrived, is that some of this we got from GitHub, but if we just take a look here, if we just look at the log file of what we actually do. So what we can do is we will run through, and this is our query that we're actually we're trying to run. So here's our query, like so. Sorry, where's the query gone? Oh, here we are, credit limit and order count, like so. Now, the first thing we can do is if you analyze the query itself, there's lots of really cool kind of analysis engines. And what we can do is we can find out data that would satisfy that query. Because if I do a find and you're not going to find the data, there's going to be 0 rows, you can't test with it. What we need to do is to find some values which would satisfy the query. So we basically go off and do that. What we'll also do then is run through looking for other customers that have a very similar profile. So we look for what we call similar data. So if you think about how most people do this, what we've done is to take on almost how humans behave, in that if they can't find the data, they'll look for some similar data and they'll update it. So what we've done is said, well, okay, let's work out what values would need to be to satisfy the query. Then let's go and hunt for similar data. And then what we'll do is we are then going to, in this case, I'm going to synthetically create a new set of orders to match to make sure the query runs. Okay. And what happens then is when we run it, we would have actually then just add in one of our generators, and the generators just picked up that they needed, whatever the values sitting behind these queries, and it's actually populated the data into the database. So you then end up with a database which actually has the data that you need. So it becomes almost part of the kind of data provisioning process. Okay, so that's a sort of a different way of thinking in terms of how you actually sort of build that data out like so. Most people are just doing ad hoc stuff. They're just putting stuff in. They might maybe at the beginning of some of the automation, they might have a small reference to a script which creates some data or something like that. But this is pretty much all you get. And what we're trying to do is say, well, let's be a bit more systematic about this and actually build some, using all the cleverness and cool technology that's out there to do some stuff like that. I'm going to just quickly talk about some of the Windocs stuff as well. Now, Windocs, is, and again, what we've done for Windocs, for you guys who are familiar with Windocs, I'm not sure if he's presented to you guys before, but basically what we've done here is we've sort of said, well, let's, I want to create a container. I want to build an image from that. I'm then going to create a container, and then I'm going to provision the image. And once I've done that, I can then come in and actually spin up my own environment. But what we've also done here is said, well, actually, when I create this environment, this is a little shipping database. What I want to be able to do here is I'm actually going to create, I'm going to supplement the data in that image. So the database that I'm going to be receiving is actually going to have 2,000 products with this kind of variety, and you can basically just add in any kind of synthetic data generation type activity that you want to the provisioning of the database. And again, we're doing a fair amount of work with, it's the sort of beginning of the sprint type work where you say, well, now we understand what's going on. We're going to actually create you some forms that when you request your environment, we're going to supplement that data into your environment, so you end up with some nice rich data. So you don't then have to immediately stop and find data. So the Windocs stuff is actually very cool. As I say, just call that Paul. That's Windocs, and you can have a look at that. So the other thing is that everything's kind of changed now in the world of just copying a production database doesn't really hack it anymore, because we now live in the world where you kind of want the real data right time, and it's not just into your environment, and it may be an upstream or downstream system. So a lot of the things that we'll do, if you think about it, is what we really need to be able to do is to provision not just data into databases. We need to create messages that then fire off across the rest of the systems. Okay, so and those messages need to work, and if they need to work, you need to make sure that they actually connect into all of the ancillary systems, all the integration systems to be able to do that. And the way that we do this is that we create a catalog of automated data lookups. Now, let me just quickly kind of show you. So the way that we do that is we say, well, okay, let's go, and anything datary that exists, and you can do this yourself, really. Sitting in your organization, there will be developers, testers, automation scripts, Jenkins scripts, which do stuff with data. And all we do is we say, well, okay, let's just put them in one place. Now, the advantage of having them in one place, it becomes like a bit of a shopping cart, so that people can kind of, be able to just go and attach them wherever. But you can also get kind of funky with this as well. So in this particular case, what I've done is I'm just going to show you the output of this, which is, we're doing a bunch of work with the Postal Service. And what they do is they've got hundreds of different message types that they need to test across numerous systems, pretty much all of their systems across the postal system internationally need to be created. So they've got loads and loads of them. Now, it's all very well the structure of it, but it's actually a lot to do with the content of it as well, in terms of how that's reflected. So you could go through and say, go create me a single message, or you could, parameterize this up and just fire a message off. But actually, what you can also think about is, well, let's build a model of the variations of messages. So all we've done is we've used the wonderful world of modeling, and within that, we're basically just building up a model. And these models are different varieties of data that we're going to play around with. Okay, so we're using modeling to design the variations, potential variations that could exist in the system. Okay, now what we'll do then is we will use some of our test, or it could be a test user case or data, whatever you want to call it. And within there, what we're doing is we're creating different variations on a theme. And you can force it down more routes. You can have many more different types of messages. Now, if we just take a look at one of these, say maybe that one, the data that's going to be passed in to the message needs to match. Okay, so you can see, obviously, we're playing around with. So here you saw we were playing around with the country codes, but we need to make sure that we have couriers that actually ship, the courier routes that actually ship with those country codes. So what we do is we say, well, that's very nice. What we've created. So this is a list of all the courier routes. Okay, so what we do is we attach to an API, we go get all the courier routes from an external provider, and that gives us all the routes. It also gives us other information which we need to care about, the different weights of the packages, standard goods, dangerous goods, and a rate schedule. Now, if we go back and have a look, what we've actually done is that we go off and we look up the courier route based upon parameters. So it's a little difficult to see in here, but basically we have a where clause from country equals country code, sender, and address. So we basically said, well, and the dangerous good indicators. So from that, we've basically gone off and retrieved information inside the model. Now, when we create the messages, which is what's kind of happened over here, we've created all these different messages. We then in effect go off and do all the lookups. We can do calculations. There's an absolute ton of things that we can do, but the idea here is what you're actually doing is you're building this set of data that is going to be inside the messages. So we would know exactly the messages that are going to go in, and then we would then post those off in effect to a Kafka queue, and they then get picked up. And that Kafka queue then just pushes that out into, on into the various business intelligence systems or the things that you're kind of driving through. So the idea is there's to sort of think about how you'd actually provision that. Now, a lot of this would be people kind of writing some Perl scripts and hacking and all that kind of stuff. So it's trying to be kind of consistent in terms of how we actually go about building those types of kind of automated processes. So I'm just going to hop to one other slide. How are we doing for time? I was going to try and stick to an hour, and then do some questions. Now, there's one other thing which this is kind of an architecture of how we set things up. So I'll just quickly whiz through what we have here. Now, what we've got really is we've got a product called VIP. I'm going to just pop into that product for 1 second. Now, VIP uses Microsoft Workflow Foundation, and it's basically the same type of tool that you would use with kind of RPA engines like UiPath, etc. It's exactly the same technology stack as that. So what we've done is we said, well, okay, we can pretty much do anything we want in here. We can connect to anything, and we can just go and pull data down, a little bit like those courier routes, for example. So you basically just create these let's have a look at this one, for example. If you're ever trying to do some looking at Swagger specs, this one, for example, is a little website that runs called Pet Store. And what we've done is we've taken the Swagger spec and we've converted that into something that we can interact with. So we can initialize it, then we can add a pet, and all you're really doing is just joining them up and then filling in the various values, etc. So this is kind of RPA, robotics process automation, for DevOps. So within here, there is just a ton of stuff that you need to push. You might want to push stuff into Google Cloud. You might want to connect to Google databases. You might want to connect to TFS, Kafka, Neo4j. There's a zillion different things you connect to, and it's very extensible. Now, this is not a secret technology. There's a lot of it around, but it's a lot easier and visual to be able to go off and actually just create that connectors in. So you connect into mainframes. We can push and pull data into mainframes, ERP systems. Every ERP comes with a set of APIs, and all we do is expose those APIs, which allows us then to drive the data that we need. We then provide a set of standard utilities, generation, subsetting, allocation, blah blah blah. But the chances are that you will have loads and loads of stuff already that you're using, and we'll just say, well, okay, let's just include that in our test data catalog. So it's something that we can structure and something that we can use to be able to kind of drive data into the systems. I'm just going to do this a little bit, and then I'll talk about some strategies. So basically create a library of automated data processes, cloning, masking, generation, etc. Expose those parameters to manual and automated tests, and to the wider community. I think that's kind of the core point. Parallel tests, parameterize and reuse data processes that as they are generated and runs. If you can use things like virtualization, if you can spin up Docker containers, you can have lots and lots of environments, and then that allows you to run stuff in parallel. And even with a even basic Jenkins script, you should be able to sort of set up 30 or 40 containers, depending on the how quickly you want to get all your testing done. You can measure the impact of data as it flows on different journeys through systems. Now, that's actually, if you look over here, sorry, just quickly show you one other little trick that we do quite a lot of. A good way of understanding, I think we were talking a little bit before just about legacy. So one of the things that we've found to be quite useful is that you can, if you snapshot a database or a set of messages and run it, and then perform some transactions on it, what we can do is actually show you the differences. And this is a very good way of being able to understand what's happening inside the database, not what you think is happening. A lot of automated tests, for example, will have a piece of SQL to say, did I create an order? And then they've got that SQL in there. A better way to do it is to say, what happened to my database, and is everything that happened to it something that I expected? And you can just use data comparison to do that. You're actually just comparing, it could be a message stack, a stack of messages, or it could be data sitting inside databases, or you could be dumping data from one of the ERP's APIs and then just actually comparing them before and afterwards. So diffing is actually a really nice way of, first of all, understanding the data, but also it's a really nice way of being able to verify that the actual results are what you expected, which obviously works very well for automated testing. So that's kind of what I mean by that. So measure the impact as it flows on different journeys to the systems, and you're sort of automating your quality gates within the DevOps pipeline. As the system moves on, I suppose the biggest problem with pretty much everything is keeping it all up to date. Something changes, you add in some extra columns. If you look at automation scripts, if you change a system, what do you do with all of your automated test scripts? You've got to go through and actually, maintain those scripts. You've got to say, do they still make sense? If I get a failure, is that because the script hasn't been updated or because the system's broken? So being able to keep all of your data up to date by putting it in a tool, changing a few parameters, adding a few extra columns, and bang, you just regenerate, for example, those postal messages. If you wanted to add in 3 or 4 extra segments or play around with some different values, then all you do is just change some of the templates, go into the model, add in a couple of extra blocks, and regenerate and generate. You're probably going to end up with the same number of messages, but you're actually just going to be have a different set of coverage profiles. So let's just move up a little bit more. feed more data from the software development side to trigger and test data jobs, so you could think, if we're doing actually some work with code analysis engines, and what you can do with code analysis engines is say, well, actually, this particular code is being tested by these tests. Now, if I change that code, I can then go off and actually say, well, let's just run those tests. We don't need to run all of the tests because the other tests don't actually touch that particular piece of code. So why bother? Unless you want to do that as a regression test, maybe once a week, just to make sure that you haven't done something like that. But you can sort of think about how you trigger stuff, and you should be auto-triggering automated tests, or as much as possible. Just within the software lifecycle, you should just be able to, as you do a Git check-in, basically add in some additional hooks or webhooks just to be able to say, well, let's just run a little analysis to see if we know anything about it, and maybe we'll just fire off a few other processes, which may well involve spinning up some images, Docker images, and adding some data in. Test data are now focusing more on subtle changes in user stories, test results, user behaviors, and more. As we're working towards sort of continuous development, where there's releases going in all the time, you basically got to be sort of a bit more nimble and think about things in a sort of slightly different way in terms of how you actually go off and do that type of stuff. Okay. Now I'm just going to jump to one more slide. I won't do this one. I won't do that one. Let's just talk about this. Now, I suppose one of the questions that comes up a lot is, where do we start, and how where do we get going? You might sort of have download one of our utilities, or you might decide, okay, we're gonna put one of our automation guys to create the data that we need. But how do you make change in an organization? Because if you're thinking about something that's affecting between 5 and 50% of the development time, and you want to get that down to between 3 and 30%, you're going to have to make some effort. You're going to have to make some changes to the way that you actually think about development. So typically, a sort of typical approach is that we will generally we'll kind of look at around an organization, and we'll look at the symptoms, because people will, why was this sprint late? And they'll say, oh, for this reason. And okay, and why are we still getting bugs on this system, even though it's been in production now for 6 months? And you look at the types of bugs and things like that. And what you're actually doing is you're finding the symptoms of something which is generally a larger problem. So what you need to do then is to say, well, okay, let's break this down using good old system analysis in terms of, right, which is the weakest part of the process, and let's try and improve that part of the process. It could be to do with speed, in that we need more data quickly. We can't wait 3 days to get the data from production. We need something instantly. Or it could be to do with quality. Let's think about having more richer sets of data available. And if you can get both of them, great. So that's sort of the second part. And then the third part is, well, what technology stack are we dealing with? Some are very difficult. If you've got a lot of legacy stuff, you might end up with all sorts of weird types of data with binary null values, in packed COBOL flat files and things like that. And you may well have to spend a couple of weeks actually attacking that hard technology to make it something that you can that you can understand, that you can analyze, that you can interact with. And when I say interact, it means you can find data in it, you can change data in it, and you can make data. Okay, so those are the sort of 3 things that you kind of need to think about when you're sort of creating your sort of new test data strategy. Fine. Then you just bite off small chunks. You don't implement a full test data strategy. It'll probably take about 18 months to get to a really, really, where you've made significant inroads to your 50% down to 30 to 20% of the time. But all you really need to do is probably tackle 2 or 3 of the key pain points initially, over the first 3 to 3 months. So, and that could be provisioning data more. A common one we do is, let's improve the data in the automation frameworks. Let's actually make that much more structured and systematic. Let's use database comparison to be able to do that. Let's use virtualization, virtual databases, so we can have more testing going on in parallel. Let's link it with maybe some of the Git check-ins, things like that. That's one initiative. Another initiative might be, let's go and talk to the people who write the requirements. Let's create a glossary of data within the organization. So if someone has a definition of a table, then that definition of a table needs to have some words associated with it. It needs to have processes which are explicit, so that other people who are dealing with test data management are not having to pick your brains or look at code or second guess. There is some kind of documentation, or it's you're pulling the stuff out into a more structured world. Okay, things like service virtualization sounds great. You virtualize all the services, but most of those services are created by hand. The content, let's just automate that. Let's just build the data into the service virtualization layer by actually synthetically generating that data. So there's lots of different places to start, and I would say it's a virtuous circle. We did actually a really great project many years ago, and what we found is the test data team became almost the source of truth, because you had, I don't know, 20, 30, 40 development teams, and they were all passing data back and forth between each other, and they were all too busy to talk to each other, whereas the test data teams, they needed. So the data that we were pushing into one team was very useful for the other team to be able to use, because they were using, maybe the business intelligence teams needed some data. And it almost like they became this sort of diplomats, because the business intelligence team thought the data looked like XYZ, whereas actually the data that was produced by the payments teams was JKW. So you had to actually kind of broker some of the differences. But once we got that moving, it worked really well. And the project, I think, initially was about 6 months behind schedule, and it only took us probably about 5 or 6 cycles to get it back on track. And that was mostly to do with the provisioning of data, of good quality data, right across the teams and fundamentally in parallel. So you didn't have teams waiting for data as well. So I think, when it comes to thinking about where do you start and what you do, hopefully that's kind of a useful way for you to kind of approach some of these sort of more interesting problems. And you're into the world of like, who's going to pay for it? Well, the project team should pay for it, but the project team don't really recognize it as a problem at the moment. So you're then going to have to go and do some education with the project team and say, well, actually, if you look over the last 5 sprints, you could probably have got it down to 4 sprints if you'd had better data, and you wouldn't have had this whole last sprint, which was fixing a bunch of bugs which you didn't find during development. So you've got to actually do some education, you've got to do some lunch and learns, and those are the types of things which are sort of more the selling and more sort of politics of people, in terms of how you kind of roll out a sort of richer test data strategy to drive DevOps, I guess. Okay, my voice is cracking at the moment, so I think I'm going to shut up for a bit. So I'll put my video back on. So just before we get started, is Tom still on? Tom, is there anything that I've missed in my ramblings?
No, I think that was a great time to have questions. I think you've covered a lot of ground there.
Okay. All right. So do we have any? Should we start with just general questions on approach, and then maybe if anyone's got any questions on specific technology stacks and ERPs and things like that. I mean, maybe I'll just ask you a question in terms of, on a scale of like 1 to 5, where 5, everything's working 100% perfect. What would most people say their test data provisioning levels are at? Is it 1, we just sort of make do, 2, we've done a bit of automation, 3, we've got it, it's linked into our test cases, 4, we've got a full automated Jenkins pipeline where we can create, everyone can have their environments, and 5, everything's fully integrated. You check a piece of code and it creates the data associated with it. What's the sort of general level, do you think, across this elite group of people?
I think it kind of depends on the situation you're in. If you're a full stack developer, might be a 1, where I need to script out my own data myself and maintain the script, maybe using like Entity Framework and maybe seed and data. But yeah, if you have more resources, you could divvy up the tasks more and have someone dedicated to like test data. So for me, it's 1.
Really? Okay. I mean, we did, still on that story, we did actually come across one bank where I think they had 300 people creating data in the bank. And we were working with another bank down the road, and they had a team of 3.
Yeah, no, I know it's important, because like that, and what I was talking about at the beginning of the call, like we're working on this fat client that's on a VM that's calling get next, and it's running into the system and doing some automation in the telnet system. So the first thing I did 2 days ago, I asked our main tester, like, well, let me see how many test cases you ran through, and she sends me an Excel document, and I was like, all right, well, I'm going to script out this data in T-SQL scripts. I'm going to run an insert script, maybe add a button to the web page so we could do that, because it's always calling get next. So that's why I'm thinking right now, because I was going to clean up this guy's code, and I'm like, I can't write a unit test for that. And like, I need to create a test harness, and that's why I went this other approach. But that's how I'm going to manage it is, let me see what you have. I'll script it out, and then I'll try to find a way you can interact with this test. So instead of her running these manual tests over and over again, because I think it's like 40 test cases, that'll take forever. We could script it out and run it through the system where it runs in 5 minutes instead of whatever it takes or hours. So
yeah,
a lot of it's very, yeah.
I mean, that sounds like a very sensible approach. Just more rigorous testing, you will explore more stuff, and also it's reusable. And I suppose the key thing there is to try and make it more accessible so everyone can do that. It's not just, because it tends to be that you get a clever person will write something and then it becomes like a secret, whereas just try and expose it, have a central portal, stick it in Jira as a form so that people can do that, and then just start creating your own little mini portal where people can request data, as and when they need it.
Hey, so we are at the bottom of the hour, so let's move really quickly to doing the gift card, and then I'll stop the recording, or I'll stop the recording. We can do the gift card spin, and then we can just leave it with open questions and answers. So, if some people want to ask a question that don't want to get it on the recording, we can do it that way.
Okay.
Sound good?
Yep.
So, I do want to appreciate, thanks for coming on, giving us, a big dose of data. There was a lot of information in there, so I really do appreciate that. And thanks for everyone also for attending. You guys, make us what we are, and we want to be able to continue these meetups, etc.